My name is Lisbeth, and today we're going to be going over finding the wavelength given frequency. So this is actually in chapter 7, which is the quantum theory of the atom, and it's one of the very first things that they go over. So here it says, what is the wavelength of microwave radiation whose frequency is 1.395 times 10 to the 10th inverse seconds? So inverse seconds this is the usual unit for frequency, and this is going to be represented by the symbol mu. It kind of looks like a fancy V. So the equation to keep in mind is that the speed of light, which is the constant c, is equal to wavelength times frequency. So this is lambda times mu. Here we're trying to solve for this guy. So I'm going to go ahead and solve for that variable so that we can just kind of plug it in later on. So when I'm solving for lambda, I have to divide by mu. So I'm going to divide by this on both sides so that these cancel. So now I have speed of light over mu is equal to lambda. Right? So wavelength, this is wavelength. Let me go ahead and write that for you. Is what we're solving for. They gave us this to be 1.395 times 10 to the 10th inverse seconds. So if I write it like this, it's the same exact thing as this. So I'm being consistent with my units. And then the speed of light is actually a constant, which is 3.0 times 10 to the 8th meters per second. This is something that needs to be memorized because it's going to be used in so many equations in this chapter. So go ahead and do yourself a favor and memorize that constant. So now let's go ahead and rewrite this so that we can see exactly what we're dealing with. So we know that wavelength is going to be equal to the speed of light, 3 times 10 to the 8th meters per second, over frequency, which is 1.395 times 10 to the 10th inverse seconds. So as you can see, the seconds will cancel. I'm going to be left with just meters. When I plug that into my calculator, I get 0.02151 meters. So that's actually the wavelength of microwave radiation at that frequency. Usually you'd want to convert it to nanometers or picometers, but in this question it doesn't specify a unit. So I'm going to go ahead and leave it at that, just because a nanometer is going to give me a really huge number. So that's going to be the wavelength. So the wavelength at a frequency of 1.395 times 10 to the 10th inverse seconds is going to be 0.02151 meters. And that's how you find wavelength.